For years, a single number has haunted shrimp cholesterol. It was labeled the silent enemy of the heart. And so, a small creature rich in protein and minerals suddenly became a suspect in the nutritional trial of the 20th century. But there is a truth, rarely discussed: the cholesterol on your plate is far less frightening than the way you cook it. The shrimp itself does not decide the fate of your meal. The pan full of oil is often the real power player. To understand this, we have to peel back layers of misunderstanding, from color and size to nutritional myths, and place them back into their proper biological context. Raw shrimp is pale gray, almost translucent. Yet, after only a few minutes in boiling water, it turns a vibrant pink-orange. What happens? The answer lies in a molecule called astaxanthin. It is a carotenoid, a relative of beta-carotene in carrots. In a living shrimp, astaxanthin does not visibly appear. It is locked inside a protein complex known as crustaceanin. This bond alters how the molecule absorbs and reflects light, making the shrimp look grayish-blue rather than red-orange. When exposed to high heat, the protein structure denatures. Weak bonds break apart. Astaxanthin is released from its molecular prison, and instantly, its true color emerges. This is a physical, chemical reaction, not a miracle. Heat does not create the pink color. It simply removes the invisible cloak that protein places over the pigment. This also explains why frozen seafood changes color in exactly the same way when cooked. Color is not a reliable indicator of freshness in the way many people assume. It is the result of molecular structure interacting with temperature. Fire writes the color, not the animal itself. Have you ever wondered why chefs often choose small shrimp for saucy stir-fries and large shrimp for grilling whole? The answer is not only aesthetic, it is about heat transfer physics. Shrimp meat is primarily made of muscle proteins, especially myosin and actin. When heated, these proteins contract and coagulate. The process turns the flesh opaque and firm, but if the temperature is too high or the cooking time too long, the structure tightens excessively, pushing water out and leaving the meat tough and dry. Small shrimp have a larger surface area relative to their volume. That means they absorb and transfer heat very quickly. In saucy stir-fries, this speed is an advantage. They cook evenly before proteins overcontract. Large shrimp, on the other hand, have a thicker core. Heat needs more time to travel from the surface inward. This allows the outer layer to develop mild caramelized flavors during grilling while the inside retains moisture. Size does not just determine price. It determines how biological material behaves under heat. Choosing the wrong size is like using thin bricks to build a load-bearing wall. The appearance may be similar, but the function is entirely different. For decades, dietary cholesterol was viewed as a direct cause of cardiovascular disease. An average shrimp contains about 150–200 milligrams of cholesterol per 100 grams, a number that made many people cautious. But modern nutrition science has clarified an important point. Cholesterol in food is not the same as cholesterol in your bloodstream. Your liver produces most of the cholesterol your body needs, about 70–80%. When you consume more through diet, the body often compensates by reducing its own production. This is a sophisticated biological feedback system. Additionally, shrimp contains very little saturated fat, a factor shown to have a stronger impact on LDL cholesterol levels. Shrimp is rich in protein, vitamin B12, selenium, and omega-3 fatty acids. The real issue often lies in preparation methods. Deep frying in saturated fats, pairing with sugary or salty sauces, that is where risk tends to accumulate. We blame the creature, while the true culprit may have been the recipe. Cholesterol is not a lone villain. It is part of a complex physiological system we once misunderstood. Standing at the seafood counter, you may have only 5 seconds to decide. A healthy label might catch your eye, but your body can make a better judgment if you know what to observe. First is elasticity. When pressed lightly, fresh shrimp flesh should spring back quickly. This indicates that protein structures have not yet degraded. As bacteria begin breaking down proteins, They produce compounds like trimethylamine and ammonia, the source of the characteristic pungent odor. Second is smell. Fresh shrimp should not smell fishy. It carries only a light ocean scent. A sharp odor is a biochemical signal of decomposition. Third is origin. Brackish water and freshwater shrimp have different mineral compositions and flavor profiles due to their environments. This affects texture and the most suitable cooking methods. Labels may claim premium, but molecular structure and microbial activity tell the real story. Once you understand that, you are no longer a passive buyer. You become someone who can read the essence behind the product.